I'm going to show you one of the rocket tests. This was, gosh, it was probably 6 or 7 years ago now, but you know, in the rocket world, that's not too long ago. So there's no sound because it would be really, really loud, or there shouldn't be sound. Hope that works out. But I think you guys will think this is really neat. So sit back and wait for it.
Oh, it's so loud. It's definitely
So that was a test that we conducted here, just out over in the yard, basically. Yeah. And it still burns for a long time. Yeah. This isn't exactly the same type of rocket that would be on something like the SLS or the space shuttle, but it uses very similar technologies, and that's something that we're trying to refine here. Make it more powerful, make it burn for longer, make it less unstable, things like that, so that it is a smoother, more reliable ride for the astronauts, and it's got enough power, enough thrust to actually get them into space, because it takes a tremendous amount of energy to get into space. You know, it's only 100 miles up, basically, is where we say space begins. But to overcome gravity and climb 100 miles takes, you know,
that much fuel.
This much fuel,
and
right?
this much person.
And yeah, for 4 people. So rocket tests like that we do here are basically just to help us get there. It's really hard. It's really hard. So we have another shuttle. We do. Here, let me show you guys another shuttle video.
Ask the question after.
I think it's this guy.
Try to if you need to write it down.
Nope, not that guy. This guy. All right. So this is what a shuttle launch should look like. I don't know if you guys have ever seen one before, to be honest. These stopped flying in 2011, so it's been a few years now. Have any of you guys seen something like this?
I know.
Yeah? Few of you? Cool. All right.
Remember
This
that
is how
Lego
we used
set?
to get into
Go ahead,
space,
my
right?
question.
That was the first model that we showed you. Obviously, we don't have any videos of the second model because it doesn't exist yet, but it will. But again, you can see that it's got the 2 rockets on the side firing right now. It had 3 rockets underneath the part that looked like a plane that are firing, just because it takes, like I said, it's not easy to go 100 miles straight up. So I think this was either the last shuttle launch or one of the last shuttle launches. I can't be sure, but I think it was. So this is this video is probably about 7 years old because we stopped flying in 2011. So that's what the SLS. The SLS will look very similar to that when it launches, but obviously it doesn't look like a plane on the outside. It looks like a rocket. So you want to talk about the water jet? Hold on a second. So hold on. We got some questions.
Oh, we got some questions. Is that Connor?
Yeah. How does fire help rockets go up to space?
It's a great question. So basically, whenever you see a rocket launching, which is what you saw, the fire is not actually what's making it go upward. A rocket is basically a controlled explosion. So the fire is just a result of the fact that we've got this massive but controlled explosion going on. So I'm going to go back to this model here. In here is basically, there's a lot of, they're not explosives, but they're like explosives. And when you light the fuse on it, all of a sudden they want to explode. But unlike a bomb, which would go everywhere, we channel it all straight down. So all of that energy, all that explosive energy is being funneled downward. Now, are you guys familiar with Newton's law of motion? Have you guys done anything like that? No? Okay. Well, when you start taking physics, you're going to learn about a guy named Isaac Newton, and you're going to learn about his laws of motion, but they basically govern our daily lives here on Earth. And the most fundamental one of which is that for every action, there's an equal and opposite reaction. So when you have an explosion that's being funneled downward, there's an equal and opposite reaction that pushes the rocket upward. Okay? So the fire is it's basically the explosion that you're seeing, but the fire itself is not what's making the rocket go upward. Does that make sense?
Yeah.
Kind of, sort of? Okay.
Awesome. Do we have one more question? Awesome. Is that Nathan?
Yeah. How long does the SLS stay in space?
How long does it stay in space?
Yeah.
So it's designed for astronauts to stay in there for up to months at a time. So it would take between 6 to 9 months to get to Earth, or to get to Mars. Whereas the moon, I think it would take about 3 days. So if you're just going to the moon, you could be there and back in a week. But if you're going to and from Mars, that's a trip that could last anywhere from over a year to almost 2 years. So it is designed for long-term astronauts, for astronauts to live in there long-term. Yes, Max.
Like, I noticed when the rocket launch that you showed us,
Mm-hmm. Oh,
I noticed that where like it was the part that was showing itself when it first was launching, they kind of closed in a little.
Say that again. They kind of.
Closed in a little.
Okay.
So are you asking
I
about
think-
what causes the thrusters to close in, or are you asking about how the thrusters are
Because you're
pointed?
seeing underneath here. I think just that. I think.
What do you mean by that?
So are you talking about, let me
Okay,
pull up
she's asking you.
the
She's
video.
asking you a question.
See. You're talking about this part right here?
Yeah.
Yeah, okay. So those parts that you see here, bring this model back over here. Let's see. What's the best way to show this here? What you're seeing there is basically this, I can't see what I'm saying here. It's this part, yeah, it's these, rocket engines right here, okay? And those are attached to the main part of the shuttle where the astronauts are up here. Now, before they actually lift off the pad, they kind of wiggle those nozzles back and forth, just as kind of like a pre-launch check. As this thing is flying up through the atmosphere, trying to get to space, they can actually slightly change, very slight, the direction of the nozzles to help kind of steer this thing. If we need to just kind of maybe tilt this way and tilt back or something like that, they can kind of change the way those nozzles are pointing. So before it lifts off, they wiggle them a little bit, A, to make sure that they're working, and B, to set them in the right orientation that they're gonna need when they lift off the pad. That's a very good question. That's actually what's called thrust vectoring. You can change where your rocket nozzle is pointing, basically. So.
Do we have another question back there? Yeah, in the back.
Where will the next rocket be launched?
Probably Florida, Cape Canaveral. That's where we've launched many times. Although, as other companies are beginning to launch rockets, so we're seeing rocket launches all over the place. So people are launching in California now as well, but the SLS will likely be launched in Florida.
Yeah. When you say the next rocket, I mean, you've heard us talk about SpaceX. I don't know if you guys have heard of that company, but they're launching rockets like every couple weeks or every couple months or something like that. And because they're mainly located in California, most of their rocket launches take place in California, but down south, and it's not anywhere around here. As far as NASA goes, Sarah is right. Most of our rocket launches do take place in Florida. This is a little bit, it's probably a little bit more information than you guys want to know, but you'll notice that a lot of rocket launches, most rocket launches take place further south, as in closer to the equator. You're not ever going to see a rocket launched this far north. There's huge advantages to being closer to the equator and launching a rocket from there. You're basically, the Earth is turning its fastest at the equator, so if you launch from the equator, you've already got a little bit of speed behind behind you.
So it makes the math easier.
And it makes it means you need less fuel.
Yeah,
to
yeah.
orbit is ultimately what it means. But unfortunately, I wish I could tell you guys that you could go down the road and see a rocket launch, but you would need to go either to Southern California or to Florida along the Atlantic coast to see one.
San Francisco.
Is there only one rocket community? Like how only like NASA launches rockets, or is there other communities?
There are a lot of organizations popping up all over the place that are beginning to launch rockets. So it kind of, back in the day, it really used to be NASA and then Russia's space program, and we were kind of dueling it out for a while in terms of who could get to space the fastest and who could get to the moon the fastest. And we know that we made it to the moon in 1969, which was really exciting. But now a lot of other countries are stepping up their game. So India has a space program now. Japan has one called JAXA. China has one as well.
There's the European Space Agency.
Yeah, there are a lot of countries do, but we're also starting to see private companies pop up as well. So we've been talking about SpaceX. That's one. There's also one called Blue Origin. And a lot of other startups and businesses are all trying to solve the problem of how do we get into space the easiest and the cheapest and the most safest. So it's a really exciting time to be in rocket science right now because there's so many different things you could do. Yes, that's it.
Is there a lot of redstone in the space shuttle spaceship?
Is there
A lot of,
what?
say that again?
Redstone.
What is redstone?
It's like a type of thing that like it's like an energy type.
He said, is there a lot of redstone, which is a type of energy in the space shuttle?
So,
What is
space
redstone
shuttle
from,
mainly-
Is it from Minecraft?
It is from
Oh, okay, so he wants to know if redstone from Minecraft is in the space shuttle.
Okay.
No, is the short answer.
Yeah.
No, the space shuttle, believe it or not, runs on almost entirely liquid oxygen and liquid hydrogen.
Which when combined form an explosion.
Yeah, you combine them and you put a match in it and they explode in a rather spectacular manner. So no redstone. It's almost. I'm not going to say that it's entirely powered by that because there's some other stuff in there, but the space shuttle basically runs on water, believe it or
Now
not.
the space station that we have, the ISS, that has astronauts living on it for almost 20 years now. Astronauts have lived up there. That is run chiefly on solar energy. So we're also seeing a lot of stuff in space being run on solar energy now as well.
Mhm.
Yes, Nathan.
How much power is used to launch rockets?
A lot. A lot. It is. Think so. If your car is, so they say cars. Well, let's say if your car is, how many cars would this be?
Yeah.
I don't even know.
What's the equivalent
A
number?
lot. Over 1 million.
I want to put it this way. Both the space shuttle and the SOS require tens of millions of pounds of thrust to get into space. Okay? So we all know how much a pound is. I don't know. You know how much you weigh, how many pounds that is. A pound is basically a unit of force. It's the force exerted on your mass by the mass of the Earth, gravity. So take however much you weigh, and then imagine that 10 million times over, and that's how much it would take to get into space on one of these guys.
That's a lot.
It's a lot.
Right there. Yes.
Oh,
Yes.
So
So
we get to your name. We get to your name sometime.
Hey,
Yeah,
do your
sorry.
name in a darker color, because they can't read the orange, I think.
Can you guys?
What's your question?
What's your question?
Yeah. Tell us your question anyway.
Can you guys name a few companies who make rockets?
Name a few companies.
That make rockets? Okay. SpaceX is one. That's probably the biggest and most well known besides NASA.
Mhm.
Blue Origin is another, and is that the Amazon one?
Well, it's Jeff Bezos.
It's Jeff Bezos. So the guy who made Amazon also made Blue Origin. So that's another one.
There's another company out there called the United Launch Alliance. They make a lot of rockets, and that's actually 3 companies that have kind of pooled their knowledge to build rockets. But anytime a satellite needs to be launched, like a GPS satellite or something like that, ULA usually launches those. SpaceX launches a lot of cargo resupply missions for the International Space Station. So the point is there's multiple rocket companies out there, and then there's NASA, and there's other.
But when I was in college, I started a rocket club, and we actually built rockets and launched them at our club. So you don't have to wait till you're a working adult to start building rockets. You can start way beforehand learning how to build a rocket.
But I'm guessing you did not launch your rockets into space.
No, not into space. They're a lot smaller than the ones we make at NASA, but it's still, a great chance to learn how to build a rocket from scratch. It was really cool. Yeah. Anybody else? Back there in the center, blue shirt.
How would the astronauts solve a problem with a hole being in the spacecraft?
Well, so very great question. This actually happened very recently, a couple of weeks ago. There was a very small hole in the International Space Station, and so the way they found out is they determined that there was a pressure leak somewhere in the ISS. So they monitor constantly to make sure they're not losing air. All of a sudden, they noticed they were losing a little bit of air. So what they did is they shut off section by section to see where they were losing air. They narrowed it down to one section. They found the spot. And what it likely was, is a very tiny asteroid probably hit the space shuttle or the International Space Station and caused a little tear. It was smaller than your fingernail, smaller than your pinky fingernail. And so they actually covered it up with duct tape. At first, it wasn't a permanent solution, but just temporarily, until they could figure it out, they just covered it up with duct tape. So duct tape works in space, which is pretty cool. Now they fixed it permanently a few days later. They mixed up some glue and some other stuff that they had on hand for this, in case of this kind of thing. They patched up the hole, and it's good as new. So that's what we would do in the case of a small hole. But for something like a bigger hole, there's a lot of procedures in place to make sure, A, that doesn't happen, and B, if it does, the astronauts can move to a different part where they'll be safe. Yeah. Yes?
No.
Professor.
Just to follow up on that, were they mixing the glue to put into the hole from inside the ISS, or was that an external EVA that they did?
I want to say it was from the inside. They actually, before they got the duct tape, they just closed it up with their finger. So like one astronaut was sitting there with their finger on the wall while the other one was grabbing the duct tape. So it was very small, smaller than 2 millimeters actually, but still visible. And definitely it still affected the pressure, so they were losing air. But we have ways to generate air and stuff in space, so it was all good.
So they patched it from inside.
From inside, yes.
Okay.
Yes, Francisco.
How dangerous is the debris in space that hits the space shuttle?
So there is a lot of debris in space, unfortunately. So back in the 1950s or 60s, there wasn't that much because nobody had ever launched anything into space before. But now we have so many things up there that they're starting to collide with one another. And when they collide, they just create a million more little pieces. And we're talking about things, they're not just driving, they're not going, a few miles an hour. They're going probably 100 times faster than your car could go. So when they're going really fast and they hit something, that is a lot of energy. You're going to have a lot of pieces floating around. So I'm actually working right now on a way to where we can manage all of that traffic flying around. When you're on an airplane, there's air traffic control where people can say, okay, airplane, you're cleared for launch, you're ready to go. That really doesn't exist right now in space. So in space, we have all these satellites which help us with GPS. They give us cell phone service, stuff like that. But they're starting to run out of space and they're starting to collide. So we're working on a way to help them communicate with one another to reduce the collision.
I just want to add something to that. When you're moving through space, as Sarah said, you're moving extremely fast. Around 18,000 miles per hour. All right. So when you're in your car driving down the highway, you're going at 65 miles an hour. Things in space are moving between 18 and 20,000 miles an hour. So even something as small as a grain of sand can have, if it were to collide with something else like the International Space Station, could be catastrophically bad, I guess. And in fact, the hole in the ISS, the International Space Station that Sarah was describing, was most likely caused by something the size of a grain of sand. So it may have ripped a hole the size of your pinky nail, but it wasn't, the thing that hit it wasn't very large at all. So it's not like you've got cars colliding in space. If you do, that's a very bad day, but a majority of the debris that's flying around out there is extremely small. Therefore, it is extremely difficult to track and to know where it is, and that presents a huge hazard to both astronauts in space and other satellites, weather satellites, GPS satellites, whatever. So it's a real problem. Wow, we got a lot of questions.
Okay, San Francisco, Delaware was first.
In the back. Yeah,
In the back? Okay.
Back, in the gray shirt.
Is it Aaron?
Orion.
Yeah,
Ari.
yeah.
Can
But we can't read your name back.
Can scrap metal be used to plug a hole in the shuttle?
I'm sorry, what?
Can scrap metal be used to plug a hole in the shuttle?
Can scrap metal be used to plug a hole in the shuttle?
I'm gonna go with no.
Yeah, I'm gonna say unlikely. It's when you have a hole in the shuttle, it's you have a living environment, air, and then you have open space. Remember, there is nothing in space, so you're gonna want to plug that up as much as you can. So something more liquidy like glue mixed with some other stuff is what you're gonna want to use to fill up, to close it completely.
And I mean, not just that, but space is a really unforgiving environment, and the things that the space shuttle is made out of, it's not like something that you can just go to the hardware store and get. So it's not assembled with wood and wood glue and screws. There's a lot of very we call them exotic materials, things that are very expensive. They're very hard to come by, but it's not like it's made out of aluminum from a soda can or something like that. So, and it's like that for a reason. We do a lot of testing to make sure that it can hold up to the pressures and heats and stuff like that we would encounter. So yeah, things like scrap metal, I don't think that's a very, very good idea. All right, is that Brenna?
Renya.
Brenya.
Sorry again.
Lovely name.
Sorry,
It's
so
okay.
hard to read.
What's your question?
Do you guys ever reuse any materials from other spacecrafts or?
Oh, absolutely.
So the space shuttle, all these guys, completely reusable because they landed. A lot of this other stuff though that fell into the ocean, they're not reusable because they're at the bottom of the ocean.
So Sarah's right. This part that looks like the airplane right here, those they flew before it ended, over and over and over again for like 20 years. They reused these things, so no problem there. These guys, they fall away while the space shuttle's flying up through the atmosphere, and they hit the ocean so hard that they're just mangled.
They get destroyed.
They get destroyed. Now, they can reuse these white things on the side with a little bit of, trickery. This orange part, no. Now, you've heard us talk about these other companies like SpaceX. They are working on ways to make the entire rocket reusable, because if you guys can imagine building something like this, where everything not even that, where everything here is not reusable, you can only use it once and then you just gotta throw it away, costs a lot of money. That's just like throwing money down the toilet. Well, it's not.
Into the ocean.
Into the ocean, right? So companies like SpaceX are working on ways to make all of this reusable and figuring out how to make it fall into the ocean in a way that it's not going to just be completely destroyed or landing it or something like that. So, yeah, it's something that we're definitely working on. All right.
Francisco's had his hand up.
Okay.
Yeah. And then we'll get to
Then we'll go to the background.
How could you prevent space junk from hitting the shuttle?
So we are able to track space junk, big and small, to about the size of a baseball. So anything smaller than a baseball, we really can't track. But the SLS or the
ISS.
the space station does have sensors, so if anything's coming near it, it can kind of tell, and then it can move a little bit. It has a little bit of a way to adjust its flight pattern, and so we're able to tell ahead of time. Okay, this guy might crash into us. Let's go ahead and move a little bit out of the way. Literally, just scooch over like a mile or so, and we'll be good. And so that's kind of what we do right now. It's not the most perfect solution, because there was a hole in the ISS the other week, but that's what we do right now.
The other thing is there's always what we call a lifeboat on the ISS. So there's always a capsule, excuse me, that the astronauts can escape to, attached to the ISS, where if there was a debris impact, they could go into this little lifeboat, eject from the ISS, and fly this lifeboat space capsule back down to Earth. So there's always a way for them to get out if it is too catastrophic. All right. Did we say background now?
Yes, background. So I think
All right.
Connor. Well, yeah, and then we'll go to the right.
Why are satellites breaking down in space?
Why are satellites breaking down?
Yeah, in space.
It can be a variety of things. Sometimes, so we know the sun gives off solar flares, and that's a lot of energy and a lot of particles and sun dust, essentially. And those can sometimes make satellites stop working. There's a lot of radiation in space, and the radiation can sometimes fry the computers on the satellites. Or stuff may hit them. There's a lot of reasons why satellites can stop working.
Yeah, other asteroids can hit them, or the other thing is, we say that space is above Earth's atmosphere, but it's not like the atmosphere just ends at a certain point, okay?